Thank you, everybody, for coming. You are all my hero this morning. I know that 9 a.m. time slot on the second day of a conference is a tough one to make, so hopefully, yes, woo! Yeah, thank you, Nick. Hopefully we've all got coffee. I have had a lot of coffee already today after staying up to work on this. So anyways, I will promise to make this hopefully engaging and interesting, hopefully answer some questions that you all have about adopting Kotlin Multiplatform in your Brownfield applications. And without further ado, let's jump in. So the big question here that I'm hoping to explore with you all is how can you start adopting Kotlin Multiplatform in your applications? And this is really going to be based on our experience answering the same questions, solving these same problems as we have been kind of exploring Kotlin Multiplatform, adopting it initially, and then kind of fast forward to today, after a year and a half, using it for more and more use cases all the time. So just a little bit about the agenda today, where we're going to go. We're going to talk first about how to get organizational buy-in. This is where we started. I think this is likely where a lot of teams will have to start, is kind of pitching the idea, coming up with the right use case for it, making sure it's worth the investment. So we'll talk about this, some of the technical things to consider, some of the human elements to consider. Then we'll spend the bulk of our time looking at some of the specific kind of technical challenges, some of the specific technical questions that we had and we felt like we needed to answer before we felt comfortable committing to a Kotlin Multiplatform approach. And then finally, we'll fast forward to today. We'll talk about some of the lessons learned, some of the pain points we've had, how we've addressed some of those, and hopefully maybe give you some mile markers, some things to look out for as you're going along this journey yourself. So by the end of this, I hope that if you are on this path, that we can put together a bit of a roadmap for you of how you could think about approaching this integration. And actually, just to kind of show of hands here for me, how many people are already using Kotlin Multiplatform in production today? Awesome. Strong presence from my team, yes. How many people are considering it or are interested in it, and that's why you're at this talk? Yes, okay, that's basically everybody else. That's a great breakdown, awesome. Perfect, we're all in the right place hopefully then. So let's start by talking about organizational buy-in here. That's definitely where we started. And I think to kind of give context to this, because a lot of this is going to be dependent on your team and your organization and the makeup of those things, I'll give some context into our team so you can kind of understand like where we're coming from, and that might help give you context into how and why we could make the decisions that we did. So for much of the last year and a half, we've been roughly 8 Android developers. We're up to 7 iOS developers now, so we have a total mobile team of about 15, which is still pretty darn small, but also just big enough where you can start thinking about things like scaling, like reusing code, wanting to be efficient in terms of developer productivity and automation and stuff. So it's kind of an interesting sweet spot for us, which is great for things like getting to explore a multi-platform solution. We're in an interesting position, a very fortunate one as an Android developer, where we're very Android first. So we're often out ahead of our iOS team in terms of building out new functionality, integrating new APIs. So that definitely comes into play when we think about a solution that, you have to admit, is a little bit more maybe Android friendly to begin with because it's Kotlin. And then also just a little bit kind of the size of our app here, we're very global. We're localized into 40 languages. We have monthly active usage on the order of a few 100,000. So again, we're not a really, really small app. We're not a super massive app, but again, big enough where being able to move quickly, validate product ideas, get to market quickly, all those things are really important. So again, that's kind of why we're starting to look at becoming more efficient and reusing code, finding a code sharing solution. And so with that said, we got tip number 1 here. So just a little Easter egg hunt here. There's going to be 5 tips. I had more, but I capped it at 5 because I figured everyone needed a hand-free. One hand would be coffee, 9 a.m. Obviously, you need the caffeine. And so we have 5 fingers for counting all of the tips. So the first tip here then is to let the problem define the solution. I think this was important for us. It's important for me personally as a Kotlin fan. I wanted to try Kotlin Multiplatform for a long time before we did. but I also wanted to be pragmatic. I felt like it was kind of my responsibility to sort of the team and the org to make sure that I wasn't just pushing a technology just because. We wanted to make sure we had a good use case for it. And so our use case was our analytics were a mess. Circa 2 years ago, 2.5 years ago, our two mobile teams, we had no coordination of our analytics. We might build the exact same feature and every event might be different. All the data was going to separate places. There was no consistency in pattern, conventions. It made digging through that a lot of work. It also made our developers have to basically rethink how they wanted to define events from first principles every time they're developing a new feature. So it was very costly from a development standpoint. It was very costly from a product standpoint. And we thought, hey, we can probably do better than this. So we got together a small team and we set about rationalizing the events for our team at Premise. And so ultimately this exercise, this was not code focused at all. Kotlin Multiplatform had not entered our minds at this point. This was basically a bunch of staff engineers, VPs, doing what they do best, working in Google Docs all day. And so, basically we set out, we enumerated a number of common event types, we defined rules, patterns, conventions for all that stuff, and we created a doc, which, I'm sure we all love to look at docs all day while we're writing our code. But this was a step in the right direction. It did give us this clear sort of set of rules, this clearly defined business logic now that both teams could draw from. But again, because we had this, a smart group that wanted to be efficient, wanted to come up with cool solutions, we thought, hey, could we codify this even further? Could we go beyond a doc, which really none of us want to have to deal with? We don't want to look at Confluence to figure out how we want to write code. We want our APIs to inform that for us. So we kind of came around to this idea. Could we have shared code for the platforms that implements and helps guide and inform this shared thinking for analytics? So this is where we kind of had the idea, like, wow, this is the perfect use case. Like internally, I'm finally like, this is my time. Like finally, my moment has arrived. It's time to pitch Kotlin Multiplatform to the team. And so I started thinking at this point, all right, how am I going to do this? Like, what is the right way to approach this? Like, what are the personality traits of other people? How am I going to convince our iOS team how to do this? And you probably have thoughts. As you start hearing that, you probably start thinking about, like, how would I pitch this and all that? I'm guessing a lot of you are not expecting how this turns out, which is that our iOS team actually suggested this first. I did not have to pitch this, which was awesome. Our iOS tech lead actually said, like, hey, I've heard about this Kotlin multi-platform stuff. You've talked about it before. This seems like it'd be perfect for that. I was like, yeah, you're right. That's a terrific idea. We should explore it. So fake tip number one then, this is the only fake tip, just find yourself an iOS team that is a bigger proponent of Kotlin multi-platform than you are. Then you don't have to be the advocate. You can just be like, yeah, that's a great idea. Let's do it. You're so smart. So the real tip then is to get to this point where there's some interest and then honestly evaluate the technical and the human factors here. So this was, again, another big thing for us. We didn't set out to just say, like, could the technology work? We wanted to make sure that it was also the right thing for our team, that people were going to be interested in it, that we could get buy-in, not just in the small group of like analytics folks, but the entire team. And so some of the things that we considered and some of the things that you would want to consider in your teams before kind of going down this path is think clearly, like, does this make sense to us? What are the exact problems we're trying to solve? And so for us, this was things like we had a clear set of business rules we wanted to codify, which makes it easy to translate into code. We wanted to share this across iOS and Android very specifically, which again, gravitates towards a multi-platform solution, but we also had thoughts around like backend sharing as well. So that kind of pushes us even more towards Kotlin multi-platform because it has that multi-target support. We knew from the get-go we didn't need or want shared UI for this use case. We also knew that we had engineers well-versed in Kotlin. Our whole Android team is pretty comfortable with Kotlin these days, been writing it as the primary language now for a couple years. And we also had engineers that were pretty comfortable with Gradle builds. This is not a tip that I called out, because again, we only get 5 for this talk. But honestly, I do think having people kind of versed in non-trivial Gradle builds is an important part of this. And if you don't want to have to deal with Gradle, it might not be your favorite solution. And then finally, just kind of the last two here, we wanted something that we viewed as relatively low risk. On the Android side, Kotlin Multiplatform is very low risk. If something goes wrong with that, you just copy the code over into your repo and boom, everything works. On the iOS side, it wasn't viewed as too big of a risk because Swift and Kotlin are similar enough. They felt like, yeah, we could probably re-implement this if we had to without too much effort. And the integration cost is fairly straightforward. And then finally, the last one here, I'll touch on this one more later, but it's also very important to have a team that is willing to sort of go outside their comfort zone to learn and wants to educate other people on the team, because this is a pretty new concept. Introducing anything new to the team sort of necessitates this, especially when it's big. So we wanted to make sure that we had a team that we felt like could be comfortable getting that, wanted to learn and try new things. And luckily, we do have a team that's like that. So that one checked out as well. So we kind of got to this point. We said, all these reasons, Kotlin Multiplatform seems to make sense. How do we actually go about validating this idea? And so this is where we started to come up with a lot of questions. And it's these questions that are kind of going to inform the format of the rest of the talk here. So we wanted to just make sure that we knew where this code would end up being stored. We wanted to make sure we knew how to actually just structure this project. How do we configure all these different Gradle models? How do we configure these build scripts? We also had to consider what targets to choose from. You know, Kotlin Multiplatform has a lot of targets available. Which ones are right for us? Is it the obvious iOS or Android, or is there some other things we could look at? We needed to explore, like, what happens if this goes well and we have multiple different kind of feature modules? How do we export that on Android and iOS? Because it's not necessarily straightforward on both of them in the same way. Then how do we output this? How do we do local builds with this? How do we make sure that we have low cost deployment of this solution? And ultimately, how do we integrate it into the projects? So basically, all of these like incremental steps were the first questions we came up with, and that was what we set about trying to figure out. So, you know, we've got this nice narrative going here. It's very clearly down a set timeline. If you'll permit me here, I'm gonna have a little hand-wavy detour here, because I don't want to quite jump into all those technical things yet. So suffice it to say that we did eventually figure out how to create a project. We figured out how to structure it, how to answer all those other technical questions. And we got to the point where I said, hey, we know how to write the code, we know how to integrate it. Now we need to ship something. We need to figure out, does this actually work once it gets out into the wild? That was the last big kind of step for us. And we had a couple schools of thought here. You know, part of me, the excited Kotlin enthusiast in me, wanted to start building out everything. Wanted to, like, let's try building out a full feature. Let's go as deep as possible as we can on this. The pragmatic part of me, and probably the better, more calmer, rational nature of the other folks involved in the project, said, hey, maybe we should start small instead. It's like, okay, fine. So we chose to KMP one small thing instead of all of the things initially. And so again, that's my next tip here. Start small. There's kind of a theme here. We started small, very small, with this one analytics, very specific problem. And then even within that, our initial version of that was super small as well. The first thing we shipped was a single string constant. It was defined in Kotlin Multiplatform. It is integrated as part of this whole pipeline that I'll talk about here in a little bit. But it was really just a single constant. And actually, the iOS team was the first team to ship it. So again, kudos to them for being involved in this from the beginning. But ultimately, that one string let us feel confident that this would get out into the wild. It wasn't going to have any weird random runtime crash or anything. We knew that our CI pipeline was in place. We knew we had the local development experience dialed in. At this point, we said, okay, yeah, like, this is working. We are now shipping this in production. And then we set about actually building out the analytics library, codifying those rules. That was actually a very interesting thing on its own, but kind of outside the scope of this discussion. But ultimately, we kind of arrived at this point. We said, we've got the green light. Like, let's do this. This is working. And from there, we haven't really looked back. So now we're going to talk about actually building this out. So we're going to go back to that detour. We're going to fill in those gaps. How did we actually start to answer those questions? What was the code we needed to write? What pipelines did we have to build? So we'll start looking into those. So tip 4 here is to think like a library developer. This was a little bit of a change for us. You know, we had one iOS project, one Android project, lots of third-party libraries on the Android side, not so much on the iOS side. But when you start thinking about how are we going to integrate this shared code, we really started to go in this direction of building kind of our first real, like, first-party library. Not technically the first one we were consuming, but like the first one that anyone currently on our team actually worked on. And so to kind of get some context as to what we're going to explore here, here's a bit of a diagram of kind of ultimately the system we sort of built out here for this initial phase and what we're going to chat through. So if I'm the developer here, I've got a couple options. I can push my code up to GitHub. From there, we have automated builds. We can then kick off runs through GitHub Actions to build our project and deploy the artifacts. So on iOS, we deploy a Swift package to a repo where we can then consume it into Xcode. On the Android side, we publish jars and AAR files to an internal Artifactory server. And we can consume those on Android and iOS as part of our production build. If we want to have a really fast, tight development cycle locally, we can do a local deployment. On Android, we can deploy those to our local M2 directory and pull those in from Maven Local. And similarly, we can sort of publish the local Swift package and integrate that into Xcode locally as well. So there's a number of small individual subsystems here that we had to figure out. And so that's what we're going to explore now. So again, we've got our primary questions here. Where will this be stored? How to structure the project? What targets to choose? Distribution, building artifacts, deployment, local test, low cost deployment, and finally, how to integrate it into the project. So let's jump in. First off, where will this code live? So if you were looking at most of the Kotlin Multiplatform examples, code labs, all that stuff out there, it's really structured around this idea of a greenfield, brand new Kotlin Multiplatform project. And in most of those examples, the code structure looks something like this. You have kind of this single repo. You then have an iOS project in that repo, an Android project in that repo, and your Kotlin Multiplatform project all in that repo. So this nice, clean mono repo, super easy to set up and get running, pretty easy to integrate. Everything's nice there. It's great. However, most of us are not sitting down to build a brand new application every day. Most of us are sitting down trying to figure out how to make magic out of these kind of crufty old code bases that we have mostly built ourselves and are responsible for. But we have to think differently here. We have to think about how do we integrate this into the existing application, thus the whole point of this talk. So, in kind of the real world, or in likely the case most of you will be looking at into integrating, you might have something that looks a little bit more like this. You probably have a brownfield existing iOS application, probably an existing Android application, maybe you have multiple iOS and Android applications. And so you might end up then with something more like this. Say, we're going to build new Kotlin Multiplatform code separate from these, but we want to consume it. So again, we have existing brownfield applications, new code we're writing in Greenfield app. Now there's kind of a middle ground here that we're not going to cover, but actually you can check out Sam's talk later today where he'll be talking about KMP for free, and I forget the name of the other tool, sorry Sam, but check it out because we were talking about this, and he's going to be kind of talking about this middle ground where it's sort of existing applications and existing code that's in those, but figuring out what of that existing code could easily be pulled out into Kotlin Multiplatform and then shared across multiple teams. So again, I think that'll be a perfect sort of follow-up to this, so check that one out. So for us, we're going to be focused on brand new Kotlin Multiplatform code, Greenfield application. So in kind of this idea, we now know all right, we're going to have a new repo. How do we actually structure the project? So we have something like this. We're going to end up with our new Greenfield project. We're going to have this sort of shared module inside of there. And in this case, I'm talking Gradle module as kind of the default build system for Kotlin Multiplatform. And within that then, by default, again, if you look at most of the tutorials, you're going to end up with something like this, especially if you're looking at the Kotlin Multiplatform mobile use case. You're going to have iOS main, Android main, common main. And that's a great place to start. But it's also worth asking yourself, are these the right targets for us? And we asked ourselves this question. There's a lot of fun Kotlin Multiplatform targets out there. iOS, JavaScript, Android, Linux, JVM, Mac, more. Awesome, I can build for all these different things. What should we actually build for? Our team actually decided that for analytics, we actually maybe didn't want Android. We actually swapped Android main out for JVM main. The reason being is we have a lot of sort of back-end services, or we think of them as our core services, that are all JVM based. And we had this idea of business events that are specifically meant to be cross-cutting across the entire organization. So we thought early on, hey, if we make these JVM-based rather than Android, we could reuse these on these other services. Now we haven't gotten that far yet. We're still working our way to that, but the idea is still alive, and this decision early on has allowed us to do that. So you might think about that as well. Do I need to have an Android target, or could I actually use JVM and open myself up for more use cases down the line? So what this looks like then in practice, if you're actually writing like a build script, you'll have your analytics build.gradle file here, or maybe shared, whatever you want to call it. But you'll apply the multi-platform plugin, and then you're going to define your target. So in our case here, we define JVM, a couple different iOS targets, and you might ultimately then define your source sets. Again, all of this is part of the Gradle DSL. So again, we have common main, JVM, the different iOS ones. You don't necessarily have to have all of these explicitly called out, but it highlights the fact that if you need to write code custom to a specific iOS architecture or something, or a different native architecture, you can. There's a lot of power that comes with the DSL, but it can be a little intimidating to get up and running with as well. And so ultimately here then, we define the individual targets, we make them all depend on iOS main, so it all just kind of comes together nicely. So at this point, we basically have crossed off the first 3 items here. We've got where the code will live, how it's structured, what targets to choose. Let's look at how we actually distribute this today. Like, what is the N+1 solution here? So again, we imagine we start off with just like this shared module, and you might think of it as like, we're just gonna put everything shared in there. But eventually you scale and start realizing that, hey, maybe it doesn't make sense to have our networking code live side by side, some helper function defining a recommendation engine or something. Maybe you wanna split those out so you have more granular control over these dependencies. So this was our N+1 solution. We thought, what happens if this goes well and we wanna put more in here? Do we wanna have this big monolithic dependency? And the answer was no. So we kind of imagined something more like this. We swapped out the shared name for analytics. And then we kind of imagined that now we have this analytics sort of feature shared module. And maybe we're going to have other modules down the line. Maybe we want DTOs, networking, recommendations, deep linking. We might have lots of things in here. How could we integrate all of these into our project? Well, it turns out on Android, it's quite straightforward. We can basically just publish each of these individually, as we'll see later. Consume them in our build scripts the way we would any other library, and this all checks out fine, very straightforward on Android. However, on iOS, this is not quite the case. On iOS, at the time that we were creating our project, and I believe it's still the case, there's a limitation with the multi-platform plugin where you can only generate one output XC framework from your project, which means we can't, if we want to have this structure, if we want to have all these feature modules kind of structured together in a single project, we can't spit out multiple XC frameworks for each of them. We have to kind of apply a little bit of a workaround here for this. So that workaround is to basically create one more module, reintroducing the idea of shared, and basically put this as a front in front of all those feature modules. So now shared depends on all these other modules. It exports them transitively in its XC framework, and now we import that into our iOS application as a Swift package. So this works great. We've been using this. This is how we ship everything today. What this looks like in a build script code is, again, we define the multi-platform plugin here. This is now in our shared module, that kind of front. And we can, in the configuration block here, we define a new XC framework. We then define, again, the targets that we want here, and we're just going to sort of iterate over all of those, sort of adding them to that framework that's built up, and exporting their dependencies so that all the code we need is included in that final binary that we include in our Swift package. And just one last step here, we also need to make sure that we add those projects as well to the, the dependencies for the source set as well, so that everything gets linked in properly. So awesome. There we go. We now know how to distribute this. So if this goes well, we know how we can pull in multiple separate modules. How are we going to actually build these then? Well, on Android and in JVM, we're generally building these two artifacts. We're building jars or AR files, depending on whether it's a JVM target or an Android target. And the thing doing all the heavy lifting for us here is the Maven publish plugin. On iOS, we're generating XC Framework like we just talked about, and then we have a couple integration options. You could integrate XC Framework sort of directly. It's kind of cumbersome. Our iOS team didn't want to do that. We chose Swift Package Manager. That was what our iOS team was starting to use. It's kind of the new thing. And so we'll look at how we sort of convert the framework into a package and consume that in. So again, if we want to build the JVM artifacts, we have this Maven Publish plugin here, and that's pretty much it. That gives us some publishing tasks that we can then use to publish our jars to Maven Local or to our remote server. If we're building the Android artifacts, we're going to have the Android library plugin here as well, and we can then add a little bit of extra configuration to our Android target for the Kotlin Multiplatform plugin, tell it to publish all the library variants if we have multiple. If you're using like a single variant for your library, maybe you can get away without this. But again, fairly straightforward here on the Android side and the JVM side. And then ultimately, when we sit down, we want to actually build this. We could run build and then, for example, publish to Maven Local, which will publish those artifacts to that local M2 directory. On the iOS side, it's slightly more complicated. We started using this multi-platform Swift package plugin to generate a Swift package from our XC framework. Now, I'll put a little asterisk next to this, which is that we've actually moved off of this. We've had some issues with this, specifically around support for M1s. I'll talk about it more at the end, hopefully. I still think this is a reasonable place to start if you're just validating the idea, but if you want your iOS team to be able to run on M1 simulators, then you probably will have to use either like a fork of this that exists, or it's also very simple to just roll your own solution, which is ultimately what we did. I think it took like 2 custom Gradle tasks. But back here in the day, and generally the way our custom tasks also work is that we apply a plugin, either that one or our custom plugin, and then we basically just define how we want that Swift package to be generated. So you got to define your Swift tools, whatever target platforms you want, and then the most important thing is the distribution mode. So you got local or remote distribution, which ultimately sort of decides where it is looking for that XC framework, which again will come into play hopefully at the end when I talk about the challenge we had. But basically this will take that XC framework, it'll generate a package.swift file, and those two things together can then be loaded as a local Swift package in Xcode, or published and consumed from a remote directory. So to generate that, again, we run build, we can run this create Swift package Gradle task, and we've got our Swift package. So again, now we know how to build those output artifacts. Let's jump into the local development deploy cycle. So again, if we run that build publish to Maven Local, that's going to drop those jars or those AAR files into the specified Maven coordinates in the local M2 directory. Then from our apps build.gradle file, we can add Maven Local as a repository to pull dependencies from. And we can pull those in, resolve those local dependencies, use those to deploy our app. This is much, much faster than publishing to CI, waiting for that build to publish to deploy, and then syncing that down into Xcode or Android Studio. This is something we've been trying to instill into our team to get comfortable doing this local deployment because it saves you so much time and it's very straightforward. On the iOS side, it's a little bit more cumbersome. Maybe it's just me. I just don't like configuring my build dependencies in a GUI in Xcode. But same thing, we run the create Swift package that generates the Swift package information for us. We then basically just go into Xcode and we load that up as a new local package dependency, rebuild the project, and Xcode will then recognize that. Subsequent builds then, if you change something and you republish that package, Xcode will automatically pick that up for you, so that is pretty convenient. But again, there we got local build deploy test, very quick, fast turnaround cycles. All right, so now how do we make that low cost when we actually deploy for real, for production? And so for us, this basically boiled down to how do we put this into CI? How do we publish these artifacts so that we can move beyond just like this local development cycle? We don't want to be passing frameworks around to each other all day. So we build all of this in GitHub Actions. So this is going to be kind of like pseudocode GitHub Actions, but the concepts will be applicable to whatever provider you're using. So we check out the code. We make sure that we're running on a Mac OS virtual machine because we need the Xcode build tools to build the iOS targets. We then set up Xcode, we set up Java, we then run the build task, and ultimately we then create the Swift package. So at this point, we've got the jars, the AAR files, the Swift package, and now we're ready to start thinking about the deployment. So just having this at least lets us validate, hey, nobody broke compilation, the tests are still passing. The next step is to automate deploy. So for the deployment, again, on the Android side, we have one plugin doing most of the lifting for us, and that's the Artifactory plugin for us because we are publishing to our local Artifactory server. If you were publishing, let's say, to GCP's artifact registry, this might look slightly different, but the core concept is more or less the same. So for us, we apply our plugin, and then basically, we just need to point the plugin to the coordinates and give it credentials to be able to publish those jar files. So this is not exactly the way it looks in the build script because the Kotlin Gradle DSL for this doesn't work quite nice, but this is how you sort of wish it looked if you were writing it from scratch. You set the server URL, you set your credentials, and then sort of last but not least here, we tell it which publications to pull in. So in our case, for the JVM case, we tell it JVM, and we include the Kotlin Multiplatform sort of default publication here, and that's going to pull in the jar and all of the metadata needed to properly resolve your Maven artifacts. So then from our Android app, we add that remote Maven server as a repository, and we add our new Kotlin Multiplatform code as a dependency like we would any other third-party dependency that we probably have hundreds of in our projects. So on the Android side there, that's pretty easy. So we can sort of update our workflow here a little bit, and we'll add a new step here, which is to publish to Artifactory. So that will use that plugin, publish those artifacts up, and at that point, they're now ready to consume in our production builds. So now we need to solve the Swift package part. And honestly, this is the part that still blows my mind that this is how it works today. Maybe it's just because I'm not an iOS dev by nature. But the way that we solved this initially, which felt like a total hack, but apparently is not a total hack, it's actually the expected way most people do it, is simply check your XC framework and your package.swift file into a GitHub repo and point Xcode at it. And that's all you have to do. And it just sort of magically works. Short of any type of like real Swift package support in something like an artifact registry, this is kind of the accepted workaround here. And it does work. It's very easy to set up. All we needed to do was take that existing framework that we had already created, and we needed to generate a package.swift file that looks something like this. And we check that into a repo. It doesn't even have to be automated. You could just you could generate that and like manually check it in if you wanted. And point Xcode at it, it works. We did manually, or we did automate this part. But once you have that in the repo, then again in Xcode you come in, you can add a new framework or library, add a package dependency, you give it the URL for that GitHub repo, you make sure that you're authenticated to access it, and you click add package, and GitHub will pull that in, it'll sync it down, it will sync the entire Git history of that repo down and then just grab the head. It doesn't do a shallow clone, which is a problem that probably not gonna have time to talk about at the end, but it is a challenge. If you run into that or you have questions, see me after. But again, now we know how to publish that. We just gotta send it to GitHub. So we'll clone down this extra repo that we set up to store this stuff. Then we generate the Swift package, we'll commit that, push it, and tag it. That's the third thing you have to do. You have to have the framework, the package.swift file, and then you have to tag it. And that tag is then going to be used to resolve the artifact version that you specify in Xcode. But that totally works. And that is how we are shipping it today. So we can run our CI builds. It's very low cost. The builds are a little bit slower than we'd like. We'll talk about that in a minute. But we're able to integrate all of this stuff into our production apps. And we have nightly builds, we have snapshot builds, release builds. So we've done a little bit more than this, but this was like the core of how all of it works. So again, just to kind of summarize this part, we end up with a solution something like this. We have developers that can do local deployments, or they can push to the remote repo. We can then do various automated workflows and GitHub Actions, publish these things to Artifactory, publish them to our Swift package repo, And then we have the option to consume these locally or from that. So we have all the options that we need here. And this is sort of where we were at then at that point where we created that one single string, we shipped it, and we started building out all the rest of what we have today. So I'll quickly try to run through this. I probably won't have time to talk through everything in depth. But basically, Kotlin Multiplatform at premise today looks something like this. We've got analytics, which was our baby. That's what we started with. But then we have some deep linking utilities. We have some performance tracing utilities, recommendations, stuff for security, sort of one-time passcodes. And then the big one that we've really been investing in the last month or so is networking. Android's been using shared networking for a while, but our iOS team is finally embracing it for real, and it's been really interesting, some of the learnings we've been having. But as you can see here, we're continuing to go all in. We're using this a lot more today than we were a year ago, and we have a lot of plans for how we could continue to adopt this. So we view this as a successful investment and something we want to continue to invest in. We have had some challenges. I'll just quickly run through these very fast. But build times, building the XC framework, doing all the linking to the binaries takes a lot of time. So some quick recommendations that we've been exploring is don't build the iOS artifacts. If you're just doing Android testing locally, save that for your CI build, save that for whoever's gonna test the iOS stuff. Maybe it's you, maybe it's someone else, but just try and avoid building anything. Oftentimes the Android side of our build will finish in 30 seconds and the iOS side takes another 8 minutes to do all the linking. So skip that if you can. Like I said, Swift package generation. We had issues with the M1 support. We ultimately kind of took inspiration from some of the other custom Gradle work we had done in this project. We looked at how some of that plugin was implemented, and ultimately we generated 2 custom Gradle tasks that generate the same Swift package file or package.swift file that we need, and it works great. And now we kind of control our own destiny. We're not reliant on a tool that hasn't been updated in a year and a half. Swift package sync time, this is another one I alluded to. Our iOS team was noticing that sometimes syncing this package would take 30 minutes and nobody could figure out why. A couple weeks ago we discovered it's because you check all these XC frameworks into GitHub, is the recommended way to do it. And suddenly that repo becomes 6 gigs in size. And because Xcode exacerbates it by not allowing for a shallow clone, you pull down 6 gigs every time you reset your cache, which apparently is all the time for our team. So anyways, the way to solve this is to actually not check the framework into the repo, actually to publish it to a remote URL. So that's that other deployment option. There was local and remote. So publish it to a remote URL. You add the SHA to the package.swift file, and then it'll pull from that instead of having to pull it from the repo. So this is something that I'm hoping to finally build for us now that this talk's out of the way and I'm gonna have time again. And this should be a huge win for our team. So this is something that you might think about just setting up from the get-go so that if your project is successful, you don't run into this down the line. API usability, this is another big one. Some of the Kotlin features we know and love, just sealed classes, suspend functions, default parameters, they don't all translate the way you would hope once they get to Objective-C and ultimately maybe consumed from some Swift. So it's a good idea to collaborate, to think about how these things are coming through so that you can build APIs that are user-friendly for your iOS team and your Android team. And then finally, the last one here is shared ownership. We've been using this a year and a half. People are excited about it, and yet still the majority of sort of the maintenance, the development, and just general understanding of the system is owned by a couple of people, generally me and Will sitting right here. So, and we want to change that though. So we've been encouraging shared ownership. We've been encouraging our team to think of themselves more as a mobile developer as opposed to an iOS or Android developer. Encouraging people to build both apps regularly, encouraging lunch and learn. So this is a big thing, I think, again, coming back to that human element. I think you want to encourage people to work on this from the beginning, which is my last tip here. So we'll just kind of close it out. Collaborate from the beginning is huge. We did a really good job of it in the very beginning, and it kind of languished in the middle, and we ran into some issues then recently as we started to ramp back up. So if you're going to invest in a Kotlin multi-platform solution, get enthusiasts, get people involved from both teams early on and continue that throughout. Anytime you're trying a new pattern, architecture, or decision, get buy-in from both teams to make sure it's going to be a good one. So just to quickly kind of wrap up here, kind of look at our 5 tips again on our one hand. Let the problem define the solution. Come up with something that actually makes a lot of sense, as maybe as a fairly self-contained problem. evaluate both the technical side and the human side. You know, if you try to invest in this and you just have a team that just doesn't want to try something new, doesn't like Kotlin, any other number of like non-technical reasons, it's maybe not the right solution for you guys. Start small. Think like a library developer if you're in this kind of greenfield library, brownfield application world. And then again, collaborate from the beginning. And maybe if I was going to put a sixth tip on here, it would have been, again, just kind of keep an open mind, ask questions. This technology is evolving a lot. The way our build scripts looked a year and a half ago is not the way they look today. It's not the way they'll probably look in 6 months. It's evolving, I think, for the better, but it also means it's kind of confusing Wild West time. So kind of get involved in the community, ask questions of people that are working on it, and we can kind of all elevate the technology together, and hopefully it'll continue to be a great solution for us in the future. So again, thank you all. Like I said, I cut out a lot of stuff, so if there's anything you want to chat more about, or if you just want to chat a Kotlin Multiplatform in general, I'm happy to do that. Find me in the hall. You can find me online at Nate Ebel. And thank you so much, and I hope you enjoy the rest of the day.